Now we're going to discuss this idea of Boyle's law. So Boyle's law generally took temperature and the amount of a gas that we have, and it kept it constant. That is very important distinction. Okay, we kept that constant. And then we varied, because in science we have to keep a couple of variables constant, and then we can vary two variables and see how they relate to each other. Hence, that's why they're called variables, right? So we varied volume and pressure, and we saw how they affected each other. And Boyle noticed that volume is inversely proportional to pressure, and this is how this is recognized. In other words, if volume goes up, pressure must come down. If pressure goes up, volume must come down. So they were inversely proportional. So that meant that volume is equal to, and one was always constant here on the top. One never changed, so it was always constant over pressure. So then if we take this and multiply P on both sides, he found that if you take the product of pressure and volume, that will always be constant. So if we have two sets of conditions, let's say P1 and V1, if you multiply P1 and V1, that will be constant. But let's say that you took a different P2 and a different V2, they would still be constant. So because of this, P1 V1 is equal to P2 V2. And that is what we call Boyle's law. And this is correct, granted that temperature and the amount of gas that we have stay constant. This is very, very important, okay? So, let us see how we can apply this law. We have to calculate the pressure of a gas that was initially at 765 millimeters of mercury and 1.78 liters, and then we compress it to 1.25 volume. So what is the new pressure? So let us identify our variables. We have P1, so that's initially, P1 was at 765 millimeters of mercury, and I recognize millimeters of mercury as a unit of pressure. All right. Then my V1 is 1.78 liters, and of course I recognize liters as a unit of volume. So then I compress this gas to decrease its volume to 1.25 liters. So I've actually decreased its volume, so I'm compressing it. What happened to the pressure here? And that is the question. What is P2? So P1 V1 is equal to P2 V2. I expect you to have those memorized, those formulas. Okay, so let's plug in P1. 765 millimeters of mercury times V1, which is 1.78 liters. And P2 is unknown times V2, which is 1.25 liters. And we can solve this algebraically, right? I guess I ran out of space. Alright, so to solve this algebraically, I just have to divide both sides by 1.25. And so I end up with P2. Now, what is going to be the units of P2? Notice my liters cancel, and I'm left with millimeters of mercury. So my units should be in millimeters of mercury. And it doesn't matter what units you are using for, let's say, volume, as long as you are using the same unit for both volumes. So if both of your volumes are in liters, that's fine, okay? Now, since your volume is in millimeters of mercury, for P1, then it also must be millimeters of mercury for P2. Does that make sense? All right, so let us do the math here. 765 times 1.78 divided by 1.25. So really, what I should have gotten was 1089, and this is millimeters of mercury. All right, and let us make sure we did. So, in other words, notice what happened. I've decreased my volume here. I've decreased my volume, so guess what? I should have estimated that my pressure will increase as a result, and that way I can check myself here. Look at, I went from 765 millimeters of mercury to 1089, which means my pressure increased. Remember that. So that's a good way to check yourself conceptually. All right. We have another example. We have a cylinder equipped with a movable piston that has an applied pressure. So I'm going to call that P1 of 4 atm. Okay. And a volume, which is volume 1 of 6 liters. What is the volume of the cylinder? So volume 2 is unknown if the applied pressure decreased to 1 atm. So this is going to go down to 1 atm. Now, couple of questions. Since pressure decreased, what do you expect is going to happen to volume? It should increase because they are inversely proportional. So I should get a number bigger than 6, most definitely, right? Now, and what would be the unit for volume 2? It would have to be the same unit as volume 1, so this must be a liter, right? So let us write our equation times P2 V2. This time I'm solving for V2, but let me plug. You can either solve for V2 before you plug numbers in, or you can plug numbers in and then solve for your unknown. It doesn't matter. I'm used to just plugging everything in first, but whatever makes sense for you. So P1 is 4 atm, and V1 is 6 liters, is equal to P2, which is 1 atm, and V2 is unknown. So I'm going to divide by 1 atm on both sides. So this cancels and I'm left with liters. You see that? So my volume 2 is simply going to be 4 times 6. And so that is 24. And what are my units? Liters. All right, perfect. So check this out. I'm sorry, I meant to put volume here. So did my volume go up? Yes, it did. It sure did. All right. So, and actually it went up 4 times because my pressure went down 4 times. So my volume should go up by 4 times. But, you should always plug in here just to make sure that you are doing it correctly. So let us do this next example, or in other words, I want you to try this on your own and then replay the video to see if you get the correct answer or not, okay? A snorkeler takes a syringe filled with 16 mils. 16 mils is a unit of volume, so let's call that V1, and this time it's 16 milliliters. He takes it from the surface, and the surface at sea level is about 1 atm, okay? So the pressure 1 is about 1 atm. All right? He takes it to an unknown depth. The volume of the syringe at this depth is decreased to 7.5 mils. What is the pressure at this depth, our new pressure? So if we decreased volume, then pressure must be going up. Okay? So then I should get an increase of pressure for P2. And what are going to be the units for pressure 2? They're going to be the same as pressure 1, which is atm. So P1 V1 is equal to P2 V2, and I'm going to solve for P2 this time. So I'm going to plug everything in. P1 is 1 atm, V1 is 16 mils. Notice I can keep it in 16 mils. I don't have to change it because they match. As long as these units, the only time that I have to do unit conversions, if V1 is given in liters and V2 is given in milliliters, that's when I have to match them up. But as long as they match, that's cool because they're going to end up canceling each other out anyway. Okay, so P2 is unknown and V2 is 7.5 mils. I'm going to divide by 7.5 mils. You see what I mean? 7.5 mils, look at that. That cancels. Oops. Not mean to do that. I just meant to cancel this out. So what are you left with? ATM. So let's do 16 divided by 7.5. So P2 should be about 2.1 ATM, because that's what unit we have left over. Now, did the pressure go up? That's good. It started being 1, and then it went up. Why? Because our volume went down, so our pressure must go up. Okay? So, let's see. If the pressure increases by an additional 1 ATM for every 10 meters of depth, then how deep is the snorkeler? So, we know that 1 ATM decrease is about 10 meters. So that's a conversion factor right there, okay? So we are at 2.1 ATM. So let us use this conversion factor. For every 1 ATM, we have gone to a depth of 10 meters. You see that? And so this is 21 meters, right? 2.1 times 10 is 21 meters. So the diver is at 21 meters when he is at this pressure.